I'm now ready to do an amplifier design using a negative image model. So we have a very simple input matching network, just a series capacitor, but this is not 50 ohms now in the negative image model. It's going to be a value that we're going to have to find through optimization. We have a capacitor at the output, inductor at the output. Now all of these are going to be negative. And we will have a port at the output here, which again will not be 50 ohms. Let's set this up in a microwave circuit simulator and see what we achieve. I've just opened up Microwave Office and I've set up the circuit with the negative image circuit model. These initial values are values I just randomly picked, more or less corresponding to what we wanted from the Smith chart representation of what the input matching network should look like and what the output matching network should look like. So let's have a look at what the gains are like with this. So I need to do an analysis. So that is done, and we'll look at the result. And here we have the gain. The gain is in the triangles. The squares are the noise figure. Noise figure on the right hand side, we see our noise figure is up around about, it's above 1 dB. 1 dB was our target. Our gain is a good bit less. Well, let me get rid of this because it's in the way. And one of the amazing things about some of the modern CAD tools is that we can use things such as tuning. So here is a tuning tool. I can select these parameters to be tunable or not. At the moment, they're all selected to be tunable. I could turn that one off or I could turn it back on again. Let's look at what happens with tuning. We have 5 parameters here we can change. The impedance of this port, it's at the moment 24.4 ohms. The capacitance here, which is our input matching network, that series capacitance has a value of minus 0.162 picofarads now. Then here is our output matching network. We have minus 0.376 picofarads, minus 0.64 nanohenry, and an output impedance of 110 ohms. So those are the 5 parameters that we can vary. We don't really need to use an optimization tool here, but we can use tuning. We just ran an analysis. We see that this is the result that we have so far with those values, not adequate. Let me look at the tuning tool. Let me see if I can find some space here for this tuning tool, and I'm going to vary the parameters. So we have our 2 capacitors, an inductor, and our 2 port impedances. So let me just play around and see what happens. I'm going to change the value of C1, the C1 capacitor, and you can see I'm actually doing a better job at input matching. I'm getting the gain up. As I get the gain up, I am getting the noise figure down. Of course, I'm hiding my gain. Well, I wanted to get up to 14 dB of gain and below 1 dB in noise figure. Let's see if I can get there. Well, I'm pretty close to getting it right, but I want it to be flat from 8 to 12 gigahertz. So the noise figure is less than 1 dB. The gain, however, is not flat. We want it to be 14 dB within 1 dB. So let me play around with some of the other tuning parameters. Well, that one doesn't seem to do it all. That certainly flattens things. We're getting closer and closer, but this gives you a lot of intuitive feel for what is happening. We play around with this a little bit more. Getting closer. I really want to get it flat. Pretty flat. I need to get that gain up a little bit though. Well, I think that pretty much is it. A little bit more tuning would get me closer, But then I still have to realize those input and output matching networks, and that is going to change things a little bit. So certainly the noise figure is quite a bit below 1 dB. It's below 0.6 dB, or reaches 0.6 dB at the top of the band at 12 gigahertz. Our gain is 14 dB within half a dB. In fact, it's never quite below 14 dB. It's up to 14.5 dB. So tuning with a few parameters enables us to get a design that roughly works, and this is using the negative image model. Of course, this circuit had negative capacitors and negative inductor values in it. We want to realize something that has much the same behavior, but we're going to use microstrip networks with multiple transmission lines in it. We would have many more than 5 parameters to vary.